How small is a molecule? I like chemistry. I like the specificity of chemistry. Actually, in college, when I decided to declare my major, I started off as being a biology major. In fact, pre-med, but that's not important. Maybe for another video sometime. But after going through biology while also continuing to take chemistry courses, I found out that I kept asking, what is this tissue made of? What is this secretion made of? I was interested in the specificity of chemistry, and so that's why I ended up choosing that as my major for college. And so, what I'd like to talk with you all today is how small a molecule is and what the significance of that is. Well, on one end, you've got something like rubber, which is a polymer, which is just a continuous strand of atoms that can continue for as long as the chemist can synthesize it. So something like a rubber tire is, now I'm not certain about this, I don't have a reference, but it can be quite literally just one single molecule, and that's a rubber tire. That's one big molecule. But on the other end, you've got something like a water molecule, which is really freaking tiny. Comparable to atoms, really, and of any element, they're really freaking tiny. So let's provide some comparisons here. First off, I'd like to compare a cup of water to stars in the universe. The NASA estimate for the number of stars in the universe is 5 sextillion. That's 5 followed by 21 zeros. Whereas a single cup of water contains 8 septillion water molecules. I just drank a burst of water. Delicious. But here's a comparison I like a little bit more. Let's compare one of your cells, one of your human cells, to a planet like Earth, a planet that we live on. An estimation for the number of molecules in a cell ranges from anywhere between 5 million and 2 trillion, depending on the cell type. And throughout time, the planet Earth has had anywhere from however few humans there have been to 6 billion, meaning that your cell is in effect a molecular planet. So what's the significance of this? Well, if you've seen any of the Star Trek movies, and you probably have, they always begin it with explaining that space is the final frontier, which, yeah, is kind of true. But I like to think that the cell, or really molecules and chemicals in general, are the real final frontier. They're really both the final frontier, and they're actually linked. We can't explore any further outwards without exploring further inwards. We need to understand how to create energy by combusting fuel and propelling ourselves forward, or having some means to travel through time or warp space around us, which requires us to have a deeper and more complex understanding of physics and chemistry in order to get further out into the universe. So in exploring one, we have to explore the other. Although we don't really need to explore the universe in order to explore chemistry, so, there's that perk. But, universe, space, NASA depends on chemistry. So, yeah. Hey, chemists are winning! Yay! You are an entire universe of molecular activity, of biological wonder. Now, whether you believe in a deity or that you were created out of the physical forces of the universe, there's no doubt that you really are beautifully and wonderfully made. And that's just your body, let alone your imagination. Have I made chemistry fun yet? Here's a question for you all. What is your favorite chemical or element? Mine is molybdenum. I just like the way it sounds. Let me know your thoughts in the comments section down below, and I will see you all tomorrow.